Okay, so now it's time for us to tell the answers to the pretest. So I'm going to go through each sample and tell you the answer. So number 1, wood fibrous look, 6120 cleavage. This mineral, number 1, is ampable. Also known as hornblende. So hornblende and ampable are two words that are interchanged. Number 2 is pure SiO2. It's pure quartz. Basically, this is crystalline quartz. Hardness of 7, scratches glass. So the answer number 2 is quartz. Number 3, important rock-forming mineral, often forms phenocryst. This is potassium feldspar, or better known as K-spar. So potassium feldspar or K-spar. Moving on to number 4. Comes in a variety of colors. Will not scratch glass. Often forms octahedrons. This is fluorite. So fluorite is the answer to number 4. Number 5, 6120 cleavage, forms a geometric shape called a rhombohedral, reacts to acid instantaneously. This is the mineral calcite. So the answer to number 5 is calcite. Number 6, this has a salty taste, cubic, 3 directions of cleavage. This is halite. It is not salt rock, it's halite because it's the more pure form. Number 7, the diagnostic feature on this, I told you, was it had a red-brown streak. It could be on the metallic chart or the non-metallic chart. This is hematite. So number 7, answer is hematite. Moving to number 8, the most diagnostic and important feature of this particular mineral is the striations. This has beautiful striations. Straight lines as they're cut by a laser. This is plagioclase. It has cleavage on one side, and that is plagioclase. So number 8, plagioclase. Number 9, the heaviest mineral of all, the one with the highest specific gravity. If you just went in the rock chart and looked at the mineral with the highest specific gravity, you'd come to Galena. Galena also has cleavage, cubic cleavage. Very heavy, very dense mineral. That's Galena. And number 10, the only mineral that a magnet will stick to can only be magnetite. So both of these pieces are magnetite. Sometimes in the industry they call this lodestone because it's loaded with iron, very heavy. So number 10 is magnetite. All right, let's move to igneous rocks. Igneous rock number 1, or number 11, the first of the igneous. This has equal distribution of minerals, black and white. Intermediate, phaneric texture, it's going to be a diorite. So that's a diorite. Number 12. Again, this texture is glassy. It is felsic. Even though it is dark in color, it has just enough iron in it to give it a mafic look to it, but it is felsic. In this particular piece, you can see some of the brown in there. And so this is simply black obsidian. Or if you want, you could call it mahogany obsidian, but it's basically brown obsidian. Number 13, aphanitic texture, felsic. This is a rhyolite. No visible minerals makes it aphanitic. Pink color makes it felsic. That is a rhyolite. Going on to number 14, Mafic Rock. Very mafic, very dark. Phaneric texture, you can actually see different minerals in this. So this rock is actually a gabbro. Its extrusive equivalent would be a basalt. Very rich in iron. So gabbro for number 14. Number 15, this is a porphyritic basalt. And what makes it a porphyry is these larger mineral of ampable or hornblende. Has a greenish textured, greenish color to it. So this is porphyritic, and this is porphyritic basalt. Number 16, we can call this tuff, volcanic tuff. And it is basically pyroclastic, it's felsic, and this is basically volcanic tuff or volcanic ash. So number 16. Number 17, the coarsest igneous rock of all with the largest minerals. This is a pegmatite texture. It's felsic because it's rich in quartz and rich in muscovite. This particular rock is a granite pegmatite or pegmatite granite. So it's a granite pegmatite. Kind of close in name, but the texture is a little bit different in this. This is actually porphyritic. So porphyritic, remember, means one of the minerals is larger and the other minerals are smaller. So you can see by looking at this that the amphiboles are small and the quartz in comparison to the potassium feldspar, the K-spar. So this is what we call a porphyritic granite. And the phenocryst that makes this a porphyry is the K-spar. So number 18 is a porphyritic granite. 19, it's just a phaneritic texture, but very fine. Very felsic rock, phaneritic texture. We just call this rock a granite. Plain and simple. Just plain, straight granite. And then number 20. Number 20, we're concentrating on the green. This is ultramafic. It is also phaneritic. You can actually see the minerals in that. And this is going to be a dunite or peridotite. So either one of those words is acceptable. Dunite, peridotite. And that ends the igneous. So now we're going to the sedimentary rocks. This rock is a classic sedimentary rock. It has sand-sized material in it, sand-sized grains. It's going to be on chart number 1. And this we're going to call, it's very well sorted, it means everything's the same size. We call this a hematitic sandstone. So the answer is 21, hematitic sandstone. Number 2, layered rock. It has what we call fissile bedding to it. Has a layering effect to it. Clay-sized minerals. We're going to call this rock a shell. So number 22 is a shell. Number 23, shell fragments all lumped together. Reacts to hydrochloric acid. This rock we call coquina. So coquina, it's a non-clastic chemical sedimentary rock. And number 24 is also a chemical sedimentary rock. This one reacts to hydrochloric acid instantly, and it contains fossils and calcite. So the sedimentary composition, calcite fossils, this we call phospholiferous limestone. So we call it phospholiferous limestone because it has fossils in it. Number 25, really important in the formation of petrified wood. So there's 3 minerals that we find in petrified wood that are quartz-based. Chert is gray, flint is black, but then the jasper is red. So we call this jasper. It'll scratch glass, chemical sedimentary. It's almost a mineral because it's comprised largely of quartz, but the red color is due to iron oxidation. Number 26, a clastic sedimentary rock, sand-sized. So this is a sand-sized sedimentary rock, poorly sorted, and it has larger fragments of potassium feldspar or K-spar in it. So we call number 26 an Arcos sandstone. So number 26 is an Arcos sandstone. 27, another classic sedimentary rock. This will be on chart number 1. Gravel-sized fragments that are angular. So these are more square, more angular. So number 27, we're going to call this a breccia. So 27 is a breccia. I'm going to skip to 29 real quick here. And 29 is also gravel size, but because the grains are rounded gravel, this is a conglomerate. So conglomerate is rounded, breccia is angular. So more angular. Both classic, both gravel size rocks. And then number 28 is another rock that fits on chart number 2. This is the true biochemical rock. and it consists of carbon and some sulfates. Very soft. It will burn. This is what we call bituminous coal. So you just can't call it coal. You have to call it bituminous coal. And then number 30, the last of the sedimentaries. This reacts to hydrochloric acid extremely slowly. It consists of calcium, magnesium carbonate. So it reacts to hydrochloric acid. It's a chemical rock, very slow reaction. And the chemical formula, calcium, magnesium carbonate, pretty much gives this rock away. So that ends the sedimentary. And I'm going to go over here to the metamorphic rocks. And so 31, 32, 33, and 34 were laid out in particular order. This follows the metamorphic grade: slate, phyllite, schist, and gneiss. So gneiss is the high-grade metamorphism. Schist is middle-grade metamorphism. And slate is low-grade. So slate is low-grade metamorphism because there's no visible minerals, dull texture to the rock. This rock can be many colors: red, green, black. If it was a red shell, it's going to turn into a red slate. So the parent rock of the slate was a sedimentary rock shell. Dull texture to it. The phyllite, a little bit higher degree of metamorphism, number 32. A little bit of shine to it. That's because muscovite and quartz start to appear. So number 32 is phyllite. Number 33 is going to be the schist. It consists of mica minerals, very visible, muscovite and biotite. And then the highest degree of metamorphism is number 34, and this is the gneiss. The gneiss has this flat alignment of the grains. So it really has a flat alignment of the grains. So these are two different minerals. The black mineral is amphibole, and the white is plagioclase. And that is a gneiss. Number 35, if you take bituminous coal and metamorphose it, the sulfates are driven out, and you're basically left with almost pure carbon, and that's what this rock is. This is a hunk of anthracite coal. So the difference between anthracite coal and bituminous coal is anthracite coal is more pure carbon. Bituminous coal has a lot of impurities such as sulfates in it, and it burns very dirty. This coal burns very clean. Number 36. This is actually in the schist family, a subclassification. It consists primarily of amphibole minerals. Therefore, the correct name of this is amphibolite. Number 37. Definitely a foliated rock. You can definitely see the layers of this. This green color is due to chlorite mica. So this rock consists of chlorite mica and some plagioclase. Foliated rock, we call this green schist. If it did not have foliation and was green, we would call it green stone. But because this has a layering look to it, we call this green schist. Okay. Number 38, a very hard rock. Its parent was a quartz sandstone. So you take quartz sandstone, put it under heat and pressure, you fuse together the quartz, you form a new metamorphic rock called quartzite. This rock is very hard. It will scratch glass. Number 39, its parent was a limestone. This is marble. You can see the large calcite crystals. This reacts to hydrochloric acid. It will not scratch glass. Number 38, the quartzite will scratch glass. So these rocks look a lot alike. And when you're out in the middle of nowhere and you pick up a rock like this, sometimes it's hard to determine. 38, which is quartzite, is going to scratch glass. It will not react to acid. Number 39 will not scratch glass, and it will react to hydrochloric acid. And then our last of our metamorphic rocks is number 40. And this is simply a metaconglomerate. Its parent was either a conglomerate or a breccia. And basically this is fused together gravel fragments. And the proper name of this rock is metaconglomerate. So this is the end of the answers for the pretest. I hope this was helpful. Study up for next week's test.